feel free to grab a seat wherever you can find one. And I know we've got a couple more people still coming in, but we have a lot of material to get through this evening, so I want to go ahead and jump right in and get started. Hi, Mary Lou. I did want to quickly introduce Ms. Mary Lou Leonard and Mr. Rick Sheen sitting up here at the front table with me. We also have several other individuals that I wanted to at least acknowledge that are here with us tonight. We have several state and congressional delegation staff members and representatives. So if those folks are willing and would stand and raise their hand if they're already standing, just so folks can see that we do have a representation from some of our elected officials here this evening. Thank you all for coming. Appreciate that. Okay, without further ado, I want to go ahead and jump right in. We do have Mr. Bill Walden just walking in as well. You're doing the clicking for me, is that correct? All right. This is a milestone meeting for us here because it is the first meeting since our submission of the Brickruff facility investigation, and so we're going to have to do our spotlight on that this evening. In order, as we do, we have these meetings quarterly. We try to time them in conjunction with information that has been recently released to the public in order to help you understand that information that is out there and give it a chance to ask any questions or clarification along those lines in conjunction with the information that has been recently released. So that's where we're going to go tonight. Quick reminder of our guidelines. There are hard copies of the presentation available. Please hold your questions till the end so that we can get through the presentation and get to the questions and comments period of our evening tonight. Ask that you limit yourself to a single question when we get the opportunity, so that all the folks here will have an opportunity. Once everybody's had a chance to ask their questions, feel free to take another turn and get another question if you have other questions remaining. We also have comment cards, so you can fill those out and get your questions addressed that way as well. Please limit, we've got a 3-minute timer here. We're going to ask you to please limit your question or your comment to 3 minutes, again, in the interest of trying to get all the questions addressed. Okay, next slide. So what we'll cover this evening, I'll give I think a one slide on the project background. We'll hit the spotlight on the report that was just recently submitted to the New Mexico Environment Department. Talk a little bit about the SVE interim measure and give you an update on that. And then do a little bit quick look forward. We have also got the responses to questions from the previous CAB at the very end of the presentation, and they're also in the handouts. Next slide. Acronym list. You know that we always have these. Next slide, please. I did want to point out one on here. We're going to talk RFI a lot tonight. And that's the worst of all the acronyms because it's got an acronym inside the acronym. So it's RCRA right above it, which is the Resource Conservation Recovery Act. And then we've got the RCRA facility investigation. And those are the documents that we just submitted to the New Mexico Environment Department last month. Okay, slide. Okay. Just a quick history. I know a lot of you are very familiar with this, but for those of you that may be here for the first time, I wanted to have you quickly go through this history. So back in from 1953 to 1999, we operated a bulk fuels facility. BFF is a bulk fuels facility. It was removed from service when we discovered that we had a leak, an underground leak over at that facility. 3 types of fuel were used within that facility. That becomes important here in a second. Aviation gasoline was used initially up until about 1975. Then we went to jet fuel, JP4. We used that until about 93. And then JP8, which is still used, although it was up until 99. We shut the facility down and we've constructed a new bulk fuel facility. Looks like we've got some additional chairs coming in, so feel free to grab one of those. Thank you very much for doing that. The soil vapor extraction unit was initially installed in 2003 to begin remediation. That was, at that point, we only understood that we knew that we had a fuel leak and it was in the soil. There was some evidence, and I did want to say this for Jim, because he pointed out before, there was some evidence of some fuel contamination in the water at that point in time. it was not, there was no free product found in the water, and we were not running that under a RCRA permit. So it was, that becomes important because we're going to talk about two RFIs that we submitted. One for the Vado zone, which is where the initial spill was discovered, and then later when we found free product on the water table, we initiated another RCRA permit, which drove another RFI, the RCRA facility investigation. So that's why we talk about two of those, one for the Vado zone and one for the groundwater. And then once we come out of the approval phase of the RFIs, then we'll have a single, we'll be talking about it from a single project standpoint. In 2007 is when we found free product on the water table, and then we added 3 additional SVE units in the 2008-2009 timeframe, and then those were all the old internal combustion engine units were replaced by a CADOX unit that was installed in 2013, and began operation, was installed in 2012, began operating in early 2013. Slide. We've shown you a different RCRA process in the past. This kind of talks to the fact that we're coming to the end of the first phase, which is that characterization phase. In the RCRA process, we really have to go through 3 steps. One is characterization, figuring out what is the nature of the problem, what is the scope of the problem, what is the size of the problem. The next one is the bottom bar there. It's called evaluation. That's where we propose methods. Based on understanding the problem, we propose a method for attacking the problem, and that's the corrective measures evaluation. We cannot do the corrective measures evaluation until we have an approved in our RFI. In our case, we have 2 RFIs, and we have to have those both approved. RCRA is a regulatory process, a statutory process, and we have to follow the RCRA rules. Those are the permits that drive our process. And so RCRA requires us to go through the characterization phase, get approval from the regulator. Once we have that approval, we can move into the corrective measures evaluation phase. Once we have finished the corrective measures evaluation phase, we get to a final remedy in place. In the interim is the middle bar there, and that's the early evaluation and initial treatment. Those are the things that we call interim measures. And you can see a variety of things that have been going on. We've showed this since 2011. The top ones there primarily focus on this set here. There are handouts that are clear. I've also got this board that maybe makes things a little easier to see. But the top ones up here all have to do with various testing. As we drilled a variety of wells and had to test all of those wells, and then began doing the soil vapor extraction, the interim measures themselves. And as I mentioned, we had our first phase, which were internal combustion engines, and then we're in our second phase with the new machine that was put in place last year, and then and we're continuing to pursue other methods. Most recently, just last month, we hooked up the existing soil vapor extraction machine to 9 additional pipes that are going into the ground. So we had them hooked up to I think we had 2 different wells with a large radius of influence. We had hooked them up into 9 additional pipes that are going into the ground in order to expand our footprint and our radius of influence with that system. And then the bottom part of that interim measure addresses our LNAPL interim measure that we are looking to put in place by the end of June, and an EEB or dissolved phase interim measure that we should have in place by the end of the year. And again, those are first iterations of those. They're not, it's not do one thing and then stop. It's an ongoing, continuous process. The important part about the interim measures is that they are things that we want to get at now in order to begin to inform the corrective measures evaluation. By putting interim measures in place, when we get to that corrective measures evaluation, ideally, we're able to simply say, what we recommend doing is what we've already got in place. Maybe modifying them, perhaps adding to them, or in some cases we may say, you know what, it's not really working very well, so we need to do something different. But it will help us to inform that corrective measures evaluation. Slide. Okay, a couple of things I wanted to point out. And I've talked to a couple of these already. We connected some additional extraction wells to the existing SVE system. We also began, it really should be the continuation but it's under a new set of cooperation, working with the regulator in an attempt to get at both the Elm Apple and the EDB portions of the Plume, and making, I guess we all set. Thank you, sir. And then we've completed the RFI groundwater model, and that is contained inside the RFI. The groundwater model that we put together is inside the RFI, and we submitted the RFIs to the regulator last month. Okay, slide. So what we want to do is, as I mentioned, that's a big deal for us, is getting into the RFI, getting that phase complete, because it helps us to end the characterization phase and get into the corrective measures evaluation and the remediation, the active remediation, the final remedy. So what is an RFI? Again, the definition is the RCRA facility investigation, and this is what it's designed to do. It's designed to determine the nature and extent of releases of hazardous waste or constituents, gather all the necessary data, and collect site-specific data with regard to the problem. These RFI reports were developed and, as I said, delivered to NID last month. Next slide. These are the highlights of that RFI report, and then we'll step through some of this as we move through the presentation. The Elm Apple and benzene plumes are stable and not migrating. The EDB plume has been delineated and is nearly a mile from the nearest city production wells. I should say that it's closer than that to Kirtland production well, and it's not in the same direction of travel, but laterally to a VA production well. But for the city of Albuquerque and the city's production wells, it's nearly a mile from there. There are several groundwater models have been released recently, to include the one that's in our RFI report, the one that was done by our contractor, and all of them show that the EDB plume will not reach the city production wells for at least 30 years. There are different models. They they're built for different reasons, but they all seem to be showing generally the same information with regard to that. We'll talk a little bit more about models here in a minute. Fuel components, including EDB, are currently being degraded through microbes in the water, natural attenuation. That is going on. That's one of the things that we discovered through the RFI process, and that is included in our RFI. We are continuing to pursue interim measures to contain and treat the contaminants. And then once we gain NMED approval for the RFI, they will represent the completion of the characterization phase. Next slide. So I'm going to talk about each of the RFIs in turn. We'll talk about the vadose zone, and then we'll talk about the groundwater RFI. The vadose zone is everything from the surface down to the water table. So it's the dirt, it's the soil, it's the sand. That's what we call the vadose zone. And we really look at it in two pieces. There's the soil itself. There's a requirement to dig up and excavate and remove contaminated soil in about the first 20 feet of the spill. So that soil, we have to go out and we have to determine where that soil is contaminated. It's called a step-out procedure. We'll show that graphically here in a minute. Basically, you go to an area, and if it exceeds the values, you step out a ways and you take another soil sample. If it still exceeds contaminant levels, then you step out again. And so it's a step-out process until you get to a point where you're not exceeding the values that are set by the state, by the regulator. Then we also have soil vapor, and it's sort of like if you've ever had a lawnmower or something that may have leaked a little oil in your garage. As soon as you walk in the garage, you can smell that. That's the vapor. Well, we have vapors that are in the soil as well, and so we are able to go down and have monitoring wells that establish and measure soil vapor concentrations as well. So we had installed 354 shallow soil borings up to 20 feet deep, and collected nearly 1,800 samples since 2011. That's to address the soil portion. We also collected soil samples during the drilling of our soil vapor monitoring wells to greater depths, all the way down to 450 feet deep. as well as some of the groundwater models. So that's not the extent of all the wells that were dug, but when we dug those, we took specific samples in order to sample the soil as we were going down to depth. And then soil vapor, we have 285 dedicated soil vapor monitoring wells. They're in 64 clusters that are at various depths throughout the Vados zone. We also have 3 clusters, the new log wells. New log is a proprietary process, and it explains at the bottom what that testing does. But we also, in addition to the 285, we had the 3 new log wells as well. The results, we found that there were, what we did is we went and took the analysis in order to come up with this information. The results are there in the second bullet. There are 10 contaminants of concern that were identified when we in the soil itself, and that's based on the meeting those criteria, more than 5% of the analyses resulting in detections, and then those detections exceeding the soil screening levels that are set by the state. Okay. They also can help us determine the spill origins by identifying where the high concentrations are in the soil. We're able to understand where the leak was and where the leak wasn't. And I think we'll have a picture of that we'll show here in just a second. Next slide. There it is. This shows the fueling site, former fuel offloading rack is what we call it. This is where the fuel came in and was offloaded by railroad car and was transferred by pipe to the pump house and then was transferred out to the storage tanks. Those storage tanks no longer exist. This entire system was replaced, about a $15 million replacement of the fuel facility. So you can see all the black dots are where we took soil samples, and if we found anything, then we would step out and take another sample. And you can see here in this area, a large concentration of contaminants were identified, and this is the inset here that blows that up. And you can see a red dot, step out until we no longer have a red dot. The leak was, we did find broken pipe right in this area, and that matches with what we're finding with the soil, but that was where we found a pipe with a hole in it. So as the fuel was being offloaded from the railroad cars and being drawn through the system, it was in that corner there where the fuel was able to leak into the soil over many, many years. Then the vapor results, so that was the soil itself. This is the soil vapor pulled from those 280 some odd soil vapor extraction wells. This is the information that we gained from that. We set up contour maps based on, again, you're drilling a single hole into the earth. We can't see down there, but we take those measurements, and by taking a variety of measurements, we're able to generate a contour map or a picture of what the soil vapor concentrations look like. So we use that information then to inform where we should put the soil vapor extraction wells in order to get at that soil vapor. Next slide. So this is an example. I told you we had 10 contaminants of concern. I'm going to show you one of those here on a couple of graphs. This is benzene. This it's a little difficult to read from the back, so let me step you through it. Again, we're at different depths. So this is about 50 feet below ground surface, 150, 250, 350, and 450. So that's what this is from about 2 years ago. This is in 2012, second quarter of 2012. So you can see you can see the line here of the offloading rack and the concentration in that area where that leak was found. Now let's go forward to the next slide. This is 1 year later. So back up one, and then go forward. So this is a year later, and you can see greatly reduced soil vapor in terms of benzene. We see, generally speaking, for all 10 components, we see a decrease in the soil vapor contaminant levels as we move forward. And all 10 of those are identified in the RFI. So this is an example of some of the information that is contained in there and what we're looking at with regard to those contaminants of concern in the soil. Next slide. Okay, now on the groundwater side, it's used for the same kinds of things. So we use it for identifying historical information about the plume, how the fuel traveled from the surface down to the water table, where it impacted the water table, how it moved or migrated once it did reach the water table. We take our measurements in order to try to characterize both the horizontal and the vertical extent of the plume in the groundwater, and identify contaminants at the site that can pose a risk to human health. Gathering that information then helps us to propose a corrective measure evaluation that will address these problems. And importantly, there's been some discussion about the fact that the Elm Apple has been swamped by rising water table. It does also allow us to get at that, assess that, and understand that portion of the problem. So again, in the corrective measures evaluation, we can propose a remedy that will address that. Next slide. So data, 117 groundwater monitoring wells installed in total. As I mentioned, following 2007, when we discovered the free product on the table, I think 83, 85, something like that, of the 80, in the mid-80s of those 117 groundwater wells were installed since 2008. So we put in a lot of groundwater monitoring wells. Again, while we were drilling those wells, we took soil samples. That's what the one bullet there talks about, our soil sampling while we were drilling the wells, and then taking quarterly samples from those wells in order to characterize the fuel flow. Part of I'm a scientist, I love to solve problems. One of the frustrating parts with this whole process is, let's get at solving the problem. Well, in order to do that, we have to make sure we fully understand the problem. And working with the regulator, they said, what you really need is installing a well and getting a sample gives you a little bit of information, but we need some of that information over time. So while we've had some of the wells installed for a period of time, we put in the vast majority of those since 2008, and we didn't complete them until 2013. And we generally want 8 quarters of data in order to meet the regulator's requirements to say that we understand what's happening there. Again, you don't want to just go out, take the temperature today and say that's what the temperature is all the time in Albuquerque. We need to understand it over time so that we have a general sense of what is happening. So that's what why the quarterly sampling has been important, and why it will continue to be important as we move into the future. Then we also conducted some tests to determine what, if any, natural attenuation, biodegradation is occurring down at the water table. And so that's what the last bullet talks about. Next slide. So the results, again, they help define the contaminants of concern. Those are the criteria that if they meet those, then we have a contaminant of concern. 21 contaminants of concern were found in the water table. Those include benzene, EDB, toluene, xylenes, and it's not to, so there are 21 there. That's not a complete list there of the contaminants of concern, but some of those include subcategories that are lumped in there, like the xylenes and some of those. And then we can determine where the contaminant of concern plumes are, their origin, and then their current extent, again, in order to inform a corrective measures evaluation. How do we get out there and solve this problem? We're going to talk about things, we'll show some slides. We'll talk about our wells. They're screened. For those of you that, like when I first arrived here, I didn't understand how all of this works. You can't just dig a hole and find a big underground lake. There's not a big lake down there. I'd say, let's go get a rowboat, get out there and get it. It's saturated sand. Think of when you go to the beach, you dig a hole, and eventually you get water in that hole. If you can hold the sand back, the hole will fill up with water. That's what we do with the wells. We put a well down there. It's got a fine screen mesh that holds the sand back, allows the water to enter into that pipe, and we can pump it out. We use that for drinking water, or in our case, we do it to monitor the groundwater in those locations. Well, we have the pipes screened at different depths. We call those shallow, intermediate, and deep. So shallow is at the groundwater, where we first hit groundwater, to about 15 feet below that. Intermediate is 15 to 30 feet, And then deep varies on the well, but can be in the 40 to all the way down to 130 feet deep, again, depending on when the well was installed and what they set the deep depth at. Okay, next slide. So this shows a series of charts now for benzene. Again, all of the contaminants of concern are contained inside the RFI. We'll go through a couple of those here. The first is benzene. This dark line is the installation boundary. Here we have Gibson and Louisiana, that intersection. This is on base. This is where the spill originated. So this is showing for 4 quarters in a row, showing the data for benzene at the shallow depths. And the key thing that we see with all of these contaminants, other than EDB, is that they are well defined, contained within this puddle. So this is where the fuel went down, made contact with the water, and spread out. Think that like a thin layer on where the water and sand and all of that becomes saturated, and it was able to spread out there and form like a lens or a puddle, maybe a pancake of fuel across that area. So you can see that there and how it seems to be fairly well contained in that particular area. We'll talk about the biodegradation that is occurring at the edges of that here in a minute. Now what we're going to do is we're going to step forward. Next slide is the same data, but now at the intermediate depths. So back up one, this is shallow. Now we go down deeper, which is at the 15 to 30 foot range, and you can see most of the benzene is non-existent there. And then go one more, which is to the deep depths, and we have no detects there. So this is generally indicative of all of the constituents except for EDB, and we'll show EDB next. Okay, next slide. So this is EDB. It's set up to the same scale. Again, you can see the lines that delineate the base and the intersection, and this is where the fuel spill originated. So this is ethylene dibromide. This is our contaminant that's of chief concern, primarily because it's migrated furthest from the spill site. So you can see there's a red dotted line. You can maybe see better in your handouts. That's the L-napple plume. So on the previous slides where we showed benzene, if we overlay all of the other contaminants, they all roughly fit inside that red dotted line, except for EDB. So we put it there so you can sort of see highest concentrations of EDB, as we would expect, are also in that same puddle, that same pancake area. But it has migrated to the north and the east. This is showing data over 3 quarters. The reason why it's 3 instead of 4 is because the last wells that were dug, that's these 3 locations, 3 wells at each location for 9 wells. Those were not complete until the 4th quarter of 2012, so we didn't have data out there. So the plume was an unknown entity up in the northeast corner prior to the 4th quarter of 2012. So this is showing it across time, and having looked at the reason why we stopped the data at this point, this is the data that went into the RFI. We continue to gather data quarterly. Quarterly reports contain all the new charts. So each quarter, as a new chart, a new report is released, all of that is available publicly, and all that information is contained out there. Having taken a look at the subsequent quarters worth of data, they continue to show basically the same kind of a pattern. Again, this is shallow. Now let's go forward. This is intermediate. So you can see that at the intermediate depth, we've got a smaller plume in this location, but it is up in the more of the northeast area, and then at the deep levels, and it's smaller yet. So we've got, this is the information that we have in the RFI with regard to, this is just 2 of the contaminants of concern of the 20 that we identified associated with groundwater. Okay, next slide. What I want to do now is I want to turn it over to our contractor who's going to talk about, those of you who've been coming regularly know that we've been talking about data gaps and the need to close out a couple of data gaps. 2 of those are the biodegradation, what was occurring there, and also the groundwater model. Both of those those data gaps were closed, which is what enabled us to submit the RFI. So I want to turn it over to Mr. Mike Onderer from CB&I, and he's going to walk through a couple of these charts with regard to the most recent data.
Okay, so I'm Mike Amara, and let's talk a little bit about
You'll have to put that.
compound-specific isotope analysis. What does that mean? Basically, microbes can use fuel components as a source of energy, as a source of food. They break fuel components down. And when they do that, you can look at the carbon isotopes, at the ratio of carbon isotopes, and that shows you what they're breaking down. So let's take benzene. Benzene is 6 carbons and 6 hydrogens. Now, there's 2 isotopes of carbon, carbon 12.
Sir, could you keep the microphone
Sorry.
closer to your mouth? We
Carbon,
can't hear you.
okay. Carbon 12 and carbon 13, okay? Certain ratio of carbon 12 to carbon 13 in the atmosphere everywhere in all of us. When microbes break the bond in benzene, it's easier for them, takes less energy to break the carbon 12 bond. Just like when we eat food, it takes a certain amount of energy for us to digest the food. So it takes microbes less energy to digest, break down a carbon 12 and a carbon 13 bond. So when you have microbial degradation, the remaining benzene that's not broken down has more carbon 13 in it. So you measure the ratio of carbon 12 to carbon 13 in the original benzene, and then as you go down gradient away from the source area, the carbon in the benzene becomes heavier. It shows that the microbes have been breaking those lighter carbon 12 bonds. So that's what compound-specific isotope analysis is. We did that for both benzene and EDB, and what that showed is that biodegradation is taking place around the edges of the NAPL plume. It's probably also taking place within the plume, but because there's a continuing source there, we don't see that change in the carbon isotope ratios. So we have a breakdown of benzene fully within the anaerobic zone. If you look back at the slide of benzene that you have over here, you can see the little red dotted line, which is in your handouts. That is the footprint, the extent of the NAPL that we have mapped over the past number of years. And you can see that the benzene concentration basically is all within that footprint, as is the toluene, xylene, naphthalene, and mostly with other contaminants are concerned. Since the spill took place many, many years ago, if the benzene were not being broken down, it would look like the EDB plume that the colonel just showed you, which shows it going off base. But basically it's contained because the microbes are breaking it down within that area. And I'll show you a map of the anaerobic zone in a minute that basically shows where that is. The data also suggests there may be slow degradation of EDB down gradient, but it wasn't statistically significant to reach a conclusion. So this shows again, here is the NAPL plume, okay? And if you look at the color of the dots, the color shows you which areas are anaerobic, no oxygen, where the microbes are busy breaking down benzene and EDB, and which areas become more and more aerobic, more and more oxygen. Background, you should have about 8 parts per million of oxygen in groundwater, and all these blue dots are up there. This is oxidation reduction potential, which is also an indication of the aerobic or anaerobic version. So basically, here's the plume. All the red dots show that it's nice and anaerobic, and the microbes are busy breaking down the benzene. But as you move further out, and this purple and this EDB plume, you become more oxidized. So that's in a nutshell what CSIA shows us. Next, I'll move very briefly to the groundwater model. We developed a model to simulate historic movement of contamination. Basically, what we did was we put the model together, designed it to match current conditions. And there are a number of other models, as many of you have seen, designed for contingency planning or for other means such as water supply management. But our model was specifically to look at, can we simulate where the plume is now based on when we think it was released and based on local site parameters. And then in the future, for the interim measures and the CME, we will project where the plume will move and use that to design our remedial technologies. So The model does match the historical movement and shape of the plume. I'll show you that on the next slide. We've developed the model independent of the field results and then said, okay, let's overlay what the model projects to what we're actually seeing and see how well it matches. And the model suggests that the fuel source actually reached the groundwater in about 1980. So the leak started sometime before that. It took a while for it to trickle down to 450 feet to the groundwater. The other thing to keep in mind is that our model and the other current models do not include any remedial activities. So they represent no action, which is not the plan. The plan is to do remedial activities. And finally, as I said, the model will be used to project future migration of the EDB plume to develop interim measures and a final remedy. Okay, one thing to keep in mind is that, water normally flows downhill, right? So these are the mountains, and here's the Rio Grande. And in 1960, the groundwater moved in this direction, as you can see in this arrow. And that's based on the contours of groundwater from that period. Now, a lot of the municipal water supply wells were put in since 1960, including the Ridgecrest wells. And basically, in the year 2000, it shows that the local groundwater movement had reversed 180 degrees and was flowing toward the Ridgecrest wells and other water supply wells in the Northeast because of the pumping. And what's important to realize about this is that projecting future pumping rates and future use of the water really affects the model. I mean, if you pump a whole lot, then the plume is going to move faster. If you pump a little, or if you adjust the pumping, it's going to move slower. So that's a key parameter to the input of your model. And you can get very different results depending on what you assume. Next, please. Okay, so this shows our model for EDB. This is based on recent data for the EDB. And the color rainbow basically is high concentration and low concentration projected by the model. And overlain with the actual EDB plume, which is this black outline. And for a groundwater model, this is a pretty good match. Now, it actually looks recently like groundwater is flowing a little bit more to the east, and we're revising the model based on more recent pumping data. So you see a little bit of a bulge here, but again, that line is based on a couple of wells in the projection. So this is a good match. What we'll then do is run this model into the future, as has been done in other models that have been released, and project when might the plume reach Ridgecrest 3 and 5, and or 5. Yeah. So the base model, once it's approved by NMED, and again, this is in the RFI report, we will start the predictive modeling. We're already starting to do this so that we can start working on our interim measure for the EDB plume. But there are 7 steps. If you remember the January KAFB meeting where we went through some of the basics of groundwater modeling, there are 7 steps to modeling. Defining the objective, which is to simulate current conditions and project future conditions. Building a conceptual model and choosing the actual model you use. We used a model called ModFlow, which is the most widely used, currently accepted, reviewed, and published model, and all the other models around. They're among the same people using ModFlow. Basically putting the site conditions, site parameters into the model, conducting model runs and calibrating it, and that sort of rainbow colored slide I just showed shows the results of the model calibration. Assessing the uncertainty. Again, remember I told you that the pumping rates are one of the key uncertainties in future projections. And then we will be performing predictive simulations to develop interim measures, the corrective measures evaluation, and final remedy. So that's the end of my talk.
Great, thanks, Mike. Okay, so then to summarize for the 2 RFIs, those investigations, the nature and extent of the contamination has been defined, has been characterized. That's why we've submitted the reports to NMED. They will look them over and they will approve them, or they will perhaps come back and say, hey, we'd like you to do a little bit more here or there. We'll work through that process, get those RFIs approved. Once they're approved, we move into the next phase, which is the corrective measures evaluation. Okay, next slide. So here are some of the next steps that we're taking. There's something called a risk assessment that is for both the Vados zone and the groundwater to identify potential human health concerns, risks. So that report will be provided to NMED here very soon. And then we also, I'm going to skip that one. Not the whole slide, just back up, please. Back up, there we go. The third, skipping the second bullet for now. The third bullet will continue our quarterly monitoring. We will implement additional interim measures for remediation as they are approved by NMED, and we have several of those that we are working with the regulator right now in order to get those installed and operational. And then, of course, once we get NMED approval of our RFI reports, then we can move to that fifth bullet, which is to complete the CME, the corrective measures evaluation, in order to define the cleanup criteria, in order to get to what we call a final remedy in place. Now that is, I just want to foot stomp that a minute from the standpoint of, we've got these interim measures that we are actively remediating the fuel plume today. But we don't have a final remedy until we go through the entire RCRA process. We have to go through that process. It's there to ensure that we adequately define the problem, characterize the problem, come up with a solution that is agreed to by the regulator, goes for a public comment period, so the public has a chance to weigh in on what the planned corrective measure is, or measures are, and then we put that in place, and that will operate for some period of time, probably a great number of years, as we are remediating the fuel. Okay, next slide. Quickly on the SVE interim measure, next. So the new system, as I mentioned earlier, was completed and began operating last year. Just last month, we connected additional extraction wells. I do want to make sure everyone aware that we will be shutting the system down, I think it was today, for about 3 weeks. We have to do some maintenance and repair. This machine runs 24/7. It's out there running all the time. Occasionally, we have to go out and perform maintenance on it, replace a motor or a blower, do some of those kind of things. So we'll be doing some systems maintenance for the next few weeks. Next slide. Did want to show this to you all. This is a mass recovery curve. The initial data, we didn't have detailed data from the early years, but this does show mass removal, cumulative, going across time, that has been accomplished by using the soil vapor extraction machines that have been in place. So this is determined in pounds. It's about 300,000, I think, if I'm reading that right. Maybe it's 3 million, I guess 3 million pounds. It works out to about 600,000 gallons, I think, is roughly what we have, that would equate to with regard to what has physically been removed. That does not take into account any natural attenuation, bioremediation, any of those kind of things. This is just the active remediation that has been ongoing. There's another way to look at this a little bit. So next chart. This shows much more recently, just beginning in June of 13. This shows total hydrocarbon concentration measured at the wellhead. So as we pull contaminants out of the ground, we can measure the concentration of what we're getting out of the ground. And we would expect, as those concentrations are going down, that we would see lower concentration levels here, which is one of the reasons why it's important for us to hook up those 9 new pipes, those 3 wells. They're in 3 clusters each. That's why I keep referring to it as 9 pipes at different depths. It allows us to get at a slightly different corner of the Vados zone in order to pull that out. So this is just another graph that shows some of the progress that's been made with regard to the soil vapor extraction. Next slide. Excuse me. Okay, looking forward. The risk assessment that I mentioned will be submitted here by the end of the month. We will also be excavating that soil. I talked about that first 20 feet of soil where we've identified that contaminated soil. That will be excavated in June. And then we have the LNAPL and EDB interim measures that we're looking to put in place this year. We have a couple of the LNAPL interim measures that we're working on. Our plan is to have the first of those in place and operating here very soon. Of course, we're going to continue operation of the existing system and look at further expansion of soil vapor extraction. Again, we'll be driven by the data as we do the monitoring and we understand where the soil vapor plume is that will drive where we're going to put those wells, or how we're going how we're going to expand that system. Then we will initiate the corrective measures evaluation following approval of the audit file. Next. Okay. We're going to get to the discussion and questions here in just a second. I did want to recover a couple of the ones from the previous meeting. A lot of these are very technical, so the answers are contained in your handouts. So we've got those there. This one talked about modeling and homogeneity and heterogeneity, and we did talk about that we did vary the hydraulic conductivity in the Air Force model, the RFI model. Did not show a large difference as we took that into account. So that was looked at, but the key driver, as was mentioned earlier, is really pumping rates. We'll talk more about models here in I think 2 questions from here. Next slide. This asked about who is handling the modeling. CB and I talked about their model, and there was some question about NMED models and stuff. This is what NMED previously stated with regard to their model. NMED reps are here if they want to talk more to their model. They can do that. And then the Water Utility Authority used a different contractor for their model. Next. Then there was a question about public inputs to the model. Again, as I mentioned earlier, the public comment portion with regard to a remediation activity comes once we've identified the problem. We're going to propose a corrective measure once we get through the corrective measures evaluation phase, and there is a set-aside public comment, public input period at that point to express satisfaction or dissatisfaction with the proposed corrective measures that are in the corrective measures plan. And then there was a question about why there were 2 models. There are actually more than just 2 models, but why different models? So keep in mind that models are used for different things. If you are the Water Utility Authority, the water is your product that you are putting out. So it's very important for them to know a worst case. When does the product that I'm providing become contaminated? So let me get a worst case situation. When could that happen the soonest? So they may run their model with a certain set of assumptions that drive to when would be the worst case when this might happen. In our situation, what we need to do is we need to make sure that we're modeling where the fuel plume actually is, because we have to go down there and remediate it. So knowing where it is as best as possible is very important to us. So we're not going to run at a worst case pumping rate situation. We're going to try to run at what our actual pumping rates, so that we know where the plume is and where it will be tomorrow, so that we can set up our corrective measures evaluation to actually get at where the plume is. So that's one example of why we might have different models. Okay, next slide. All right, what we want to do now is we're going to open it up to questions from you all. We talk about questions associated with the material presented here, other questions that you may have. I do just want to reiterate, here are the rules we talked about before, so please abide by those so we have an opportunity to get as many people engaged as possible. We have a moderator. I'll give him a microphone here so that he can come around and he will make sure folks have an opportunity to be heard.
The first question should be, why can't you find a large
Hold on a second, sir.
Excuse me, sir. That was a good question. So I do want to.
Before, and it's been standing room only.
Excuse me, sir. Sir, we're not going to do this. We're not going to just start shouting questions. Okay? We have a procedure. We're going to go through. We're going to make sure folks have an opportunity to be heard. It's very important to me that you all have an opportunity to be heard. It's important that we present this information. We've been promising it. We told you we're going to present it. We have to present it. It's important. But it's also important that we get a chance to hear from you all. So what we're going to do is go ahead. The gentleman back here has first one had his hand up.
So I'm going to go over the rules again real quick. There's 3 minutes per question. Please, I'm going to time you up here also so you'll see it. At 2.5 minutes, I'll show you the timer so you know if you've been making a point or getting a question out, to get the question out. We have over 100 people here. I tried to count them all. So please abide by that rule. I'm looking around. It might be hard for everybody to come up in a line, so you'll get your turn after them, sir. But no shouting the questions up. Please abide by the 1 question rule. We have a lot of people. Come on up, sir. And just get my attention, and I'll point out to you. And yes, ma'am. And if you have a question you don't want to ask and you want to write it down and hand it to me, I will ask it for you and see that it gets answered.
Yeah, I have a question about, on page 6, under your RFI highlights, on the bottom slide, you have a bulleted point that was surprising to me. It says, fuel components, including EDB, are currently being degraded by microbes in the groundwater. And that surprises me, because if that were true, that would constitute a real scientific discovery, since EDB doesn't biodegrade. So this is, I mean, everyone should just go ahead and cross that off of your file. So, I don't know, was it Mike Ember? I'm sorry, I didn't get your last name. Right, so I mean, you said that there's nothing statistically significant about EDB biodegradation in the plume. That's what you said. Yeah, well, there's no, I mean, there's one thing that's true about EDB is that it persists in groundwater and soils. It's been there for 40 years at high concentrations. So what is the evidence exactly that you have of EDB biodegradation? Because everything I've learned about EDB doesn't. It doesn't biodegrade, instead it persists. My name is David Correa.
He's gonna answer, yeah.
What I had said was that there is evidence that EDB is degrading in the anaerobic zone, which is the area right around the Neville footprint. And studies at Massachusetts Military Reservation with another large plume has shown it as well. EDB generally is not thought to biodegrade in the aerobic zone. And as I mentioned, there's a suggestion that the carbon-13 is getting heavier in the aerobic zone, which implies some additional degradation, but it's not statistically significant. But in the anaerobic zone, the CSIA analysis shows that the carbon 12 is preferentially being broken down, which indicates microbial degradation. And there's some other indicators as well that are addressed in the RFI.
There was a question, I was not somebody over here. Oh, come on. Please remember to say your names.
Victor Work. Colonel Land, thank you very much. And you were concise, and let's say more concise than most. When you say you're a scientist and you like to solve problems, how long do you foresee yourself being on this project?
Sorry, how long do I see myself here at Kirtland working on this project?
Yeah.
I'm here on a 2-year assignment, so this is a 2-year assignment for me.
Would you like to make it, do you feel that there's dedication within the Air Force to see this through? And if there is, why does the scientist who seems to have such a great grasp on it going to be shipped out after 2 years?
I'll tell you what, sir, I'll let you ask all your questions, and then, do you have more? Please don't take the mic from him if he's got, I mean,
Well,
I know-
question that I could handle in 2 minutes.
Okay.
I'm just trying to get a sense for his dedication to the project.
If you have a point we're getting to, then I'll be happy to talk with you about.
I'd like you to talk a little bit about your dedication as a person who lives in Albuquerque, as a person representing this great force, the Air Force, to getting this project done.
Got it, thank you. Well, asking an Air Force officer about his dedication is a softball question, highly dedicated. And as I've mentioned to this group before, I grew up in the West, I love the West, that's why your inputs are so important. Because I represent the government. A lot of people holding up signs before I even start saying anything, they're telling me I'm lying. But I'm not. I'm dedicated to keeping the water for the people of Albuquerque clean, and the Air Force is dedicated to that. And that's much more important, because as an Air Force officer, I will come and go, and new folks come in. And I think it was a good thing that the new Air Force officers come into play, come into this program, and ask tough questions. You've got to convince us. So I will hand this off to my successor when he arrives, and he will ask tough questions, and he will need to be convinced. I'm not the only one working on this project, however. We have a base civil engineer who's been here in Albuquerque since the mid-1970s and is not going anywhere. And he's very dedicated to this project and spends an enormous amount of time working on this project. We have the base installation commander gets weekly briefings on this. He's very dedicated. We have This project is the #1 Air Force environmental concern, and that's saying a lot. I don't normally get to stand up in front of a group meeting, and it's not me. It's unusual for an Air Force officer to be able to stand up and say, the Air Force owns this problem, and we are committed to fixing it. Because normally you don't have the kind of top cover that you need to be able to say that. I have that top cover, because the highest levels of the Air Force are committed to maintaining safe drinking water for the city of Albuquerque and the people of Albuquerque. So, sir, that's the best answer I can give you on that. Will I be reassigned? Yes, I will. And so I will move somewhere else, I'm sure. But that doesn't mean I'm not dedicated while I'm here, and the individuals who come behind me will be as dedicated.
Hi, I'm Lisa Crane. I'm with the Answer Coalition, and I'm looking for further clarification on the issue of microbes degrading EDB. So let's assume that it really does happen, although we've heard a different opinion that in fact microbes do not degrade EDB. But the clarification I'm looking for is straight out, non-technical language. Are you saying that if the microbes do degrade the EDB, that it magically turns into some innocuous substance, or does it turn into just a variety of other noxious substances?
Thank you for the question. Mike, are you able to talk about what it degrades into?
I don't have the specific degradation process with me in my head, but we can provide you the answer. But it does basically break the carbon bonds apart and pull the bromine off, and you end up with bromine, which is basically like chlorine. If you have a hot tub, you put bromine in. I'm sorry. It breaks the carbon bonds and pulls the bromine off. Eventually you end up with bromine ions like chlorine. Bromine is something, I have a hot tub, I put bromine in it instead of chlorine to disinfect it. So ultimately it'll break down to bromine ions, carbon dioxide, and hydrogen once it's oxidized.
That's a good question. Let me make one point of clarification. There was no intent to say, hey, look, we think we've got some natural attenuation, some microbial degradation, so we're good. There's none of that. That is not at all what we're talking about. 30 years on the models to get, that doesn't mean, again, hey, we've got time, let's go out for dinner. We are aggressively pursuing the remediation of this fuel plume. We are doing it in conjunction with our regulator, the New Mexico Environment Department. Everything that we do, every step we take, every hole we drill, everything we put in place, we take it to the New Mexico Environment Department for their approval. So we are going to continue through that process, and we are aggressively going after El Napo, EDB, and the Bay Basin.
Hi, I'm Dr. Robin Falkov of Health Freedom Rights. My radio show is Event Horizons. It's a morning news show. I have an afternoon show, What They Don't Want You to Know. And I'm listening to everything everyone is saying here. I've been living in New Mexico for 15 years, and I find this a disgrace. How can you say this is being aggressively worked on when 30 plus years of contamination is known and nothing has been done to remediate this problem? I find it horrifying. I'm also a physician. To say that 24 million gallons of toxic chemicals are fine to remain in the water, it's insulting, it's an outrage. I mean, does the city and does the Kirtland Air Force Base think everybody is just as dumb as dirt, that it won't make a difference? When does the remediation start? I think there's been a long enough time for all these years that the cost benefit has been well balanced out. So whatever you put in now for doing nothing all this time is covered. When does it begin? There's no cleanup at Los Alamos. I ask people about all these EPA sites and there is no cleanup going on. Well, that's my question.
Cleanup is occurring now. Thank you very much for your question. I disagree with you. Cleanup is actively taking place. We've got systems that are in place that are remediating the fuel plume. We cannot get to the final remedy, what is called the cleanup, that portion. We have to abide by the rules. We have to go work with the regulator. We have to abide by the legislatively required process, which is RCRA. So we are working through that process. In the meantime, we have interim measures in place. We are adding to those regularly, and we are actively addressing the issue. No one thinks the people of Albuquerque are dumb or they're very intelligent. That's why it's important for us to come here and explain things to you. You can not agree with what I'm saying. You cannot believe what I'm saying. That's fine. But I owe it to you to tell you what it is that we're doing as we work through this problem.
But with 30-plus years, it doesn't make sense,
Yeah,
that there's no.
I'm not sure, we've had your question already, and 30-plus years is not an accurate statement.
I'm coming around, I promise.
50-plus years, actually.
My name is David McCoy. I'm the Executive Director for Citizen Action in Mexico. I take it some of you are not here because you're following in agreement with what you've heard before from the Air Force. I'd like to talk first about this CAB situation. It's not like any citizen advisory board I've ever seen set up anywhere. There's the Air Force always sets the agenda. There's no record kept for what the public says. There's no minutes kept for the meetings. There's no public membership application process with a mailing to people that might be on the mailing list. The CAB members are not posted on the Kirkland website. They're not identified after meetings. There's no identifying plaques in front of any of the CAB members. It operates without a roll call, without any quorum. The CAB doesn't offer any advisories that I've heard to Kirkland, and the CAB members rarely have anything to say. Their attendance at meetings is unknown. Where's the chairman? Anyhow, that's just with respect to the CAB. There's other problems. This RFI characterization is completely inaccurate. If you looked at the maps that were presented to you, there's a 4,000 foot area between the monitoring wells and where the municipal wells are placed. Now, the